Okay, I hope it has started. Yes. Let's continue with postulates of Bohr's. The last postulate that we did is where we derived the expression for velocity and the expression for radius of the atom in Bohr's orbit. Then I think we did some numericals based on those. And now we derive the expression for total energy of the electron in Bohr's orbit. Now, can someone here? Asha, this is people from the second postulate where we say that the force of attraction between the electron and the nucleus is balanced by centrifugal force. Okay, we need this in order to do the energy expression. Second हमने क्या किया था? I want to now find first the potential energy. So center में let's say we have nucleus and यहाँ पे what do we have people? The electron revolving around the nucleus in circular orbit. What was the expression for potential energy? The expression for potential energy is K Q1 Q2 over R. Yes or no? Chalo. Now what is Q1 over here, people? We can consider the nucleus to be Q1 and the electron to be Q2. What will I write Q1 as? It is the number of protons which are present inside the nucleus. So how many protons are there inside the nucleus? Hydrogen atom ke liye it is 1. But if I want to write a general expression, what will I write there? Z. Each having a charge E. But what will Q2 be? Charge on an electron? E. Yes or no? But if you remember, when we did the same potential energy expression, if you go back, तो हमने ना तीन conditions लिखे थे, where Q1 and Q2 both are positive, Q1 and Q2 both are negative. When Q1 is positive and Q2 is, in the first two expressions where Q1 and Q2 both were positive, the potential energy was also in when Q1 and Q2 both were, which means negatively charged particles, the potential energy was still positive. But when Q1 was positive, which is the nucleus, Q2 is, potential energy is going to become negative. Did you people get that? So potential energy here is K. In place of Q1 I can write Z times E. Q2 I can write negative E over R. So potential energy का expression क्या मिलता है people over here? Minus K Z E squared over R. Now we can start the derivation for total energy. Now people, total energy is the sum of kinetic energy plus potential energy. Total energy is the sum of kinetic plus potential. We already have the expression for potential energy. What is that expression? Minus K Z E square by R, K Z E square by R. But we don't have the expression for kinetic energy. What is the formula for kinetic energy? Can someone give me the formula for kinetic energy? Half mv squared. Do you see mv square somewhere on the board? In place of mv square, what can I substitute? Half k z e squared over. Did you people get that? Anyone who did not understand that? कहाँ से मिला ये? So this gives me the expression for kinetic energy. Yes or no? बोलो रे. And now tell me people, can I say total energy is, how much is kinetic energy given? Half kz e square upon r plus, how much is potential energy? Minus kz e square over r plus minus, so it will be half kz e square by r. This is going to become negative kz e square over r. Do you find something common? What? Kz e square over r. What is left in the bracket inside? What is half minus 1? Half, negative half. So what is the formula for total energy? Minus half kz e square over Did you people get that till here? Now compare the values and tell me, what do you observe? If I compare total energy with kinetic energy, what do you see? I repeat, compare total energy and compare kinetic energy. Total energy is equal to negative of kinetic energy. Can I say that? Now compare total energy and potential energy. I repeat, compare total energy with potential energy. कितना मिलता है? Can I say total energy is half of potential energy, or the same expression can be written as potential energy is twice of total energy? And last, compare for me potential energy and kinetic energy. Potential and kinetic, what's the relation? Potential energy is negative half of kinetic energy. With me till here? Yes or no? Now go back to the derivation of radius. I'm sorry? उल्टा लिख दिया ना मैंने. It should be negative 2. It's twice of, pardon me, kinetic energy. Now go to the derivation of radius and tell me, we got an expression for radius. Radius का expression क्या मिला था हमको? h square over 4 pi square mke squared into n square by z. We got this expression for radius. Substitute that in total energy. Total energy का formula क्या है people? Minus half into kZe squared into, I've just expanded the form, थोड़ा split किया है बस. Why? Because in place of this 1 by r, what can I substitute? Negative half into kZe squared into. This will become the reciprocal of what we have. So 4 pi square m k e square upon h squared into z upon n square. With me till here? So total energy is 2 ones are 2, 2s are. Now let's see if I can cancel something or bring some common terms together. K and K will become K squared. In negative, I'll keep here. Z with this Z is going to become Z squared. E square is going to become e raised to 4. 4 pi square. This 2 and this 4. What is that going to become? 2. This pi squared m. Anything left from the numerator? Denominator. Denominator में ये 2 और ये तो cut हुआ था. What do we have here? H squared. Anything upon n square. Why the difference in color? All this here, these are constant terms. Okay? So the expression for total energy is negative when you substitute all the values of constant. 2.18 into 10 raised to minus 18 into z square over n square. This is the formula when you want to calculate the energy in terms of joules per atom. And if you want to calculate this in terms of electron volts, minus 13.6 into z squared upon n square electron volt. With me till here? Chalo. With reference to this formula, what is the energy of hydrogen atom, the electron, in the first Bohr orbit of hydrogen atom?
Minus 13.6.
Z will be 1. E will be, sorry, N will, how much is that? Negative 13.6. What is the energy in the second orbit? Minus 13.6 into 1 square by 4. How much will that be? Minus 13.6 by 4, that is approximately minus 3.4 third orbit. So can I say the value starts from minus 13.6, then it is becoming negative 3.6, then it is becoming negative 1.8, it is decreasing. Eventually it will reach, if I put n is equal to 4, n is equal to 5, n is equal to 6, what is going to happen to the value of E? The value will keep on, and it will reach, or it will tend to reach what value? 0. Nahi samjha? Do you want me to explain that again? Yes. I repeat, I have negative 13.6 into z square is 1 square upon in the first orbit. N का value is, so answer कितना होगा? Negative 13.6. Put n is equal to 2. What do you get? Negative 13.6 upon 4. What was the value first? Minus 13.6. Next value क्या है people? Minus 3.4. Keep going ahead. If I put negative 13.6 upon 3 square, how much is 3 square? 9. So how much will that be? Negative 1.5, somewhere around that. If I put 4 square, तो कितना होने वाला है वो? Minus 13.6 upon somewhere around 0.8. So what's happening to the values? Eventually it will become, it's not that the energy of the electron is becoming 0. First, energy, the negative sign here indicates that the nucleus has a hold on the electron. Try to understand this. I repeat, the nucleus has a hold on the electron. As the electron moves away from the nucleus, first orbit, second orbit, third, fourth, fifth, sixth, seventh, eighth, the value is approaching 0, which means that at a certain point, the nucleus will not have any hold on the electron. Did you people get that? Please respond, yes or no? And this can also be seen in various different ways. Potential energy का formula होता है K Q1 Q2 upon R. Potential energy is inversely proportional to, as the radius of the atom will increase, potential energy will keep on decreasing, which means as the electron will start moving further from the nucleus, the energy will go on decreasing. That energy, I repeat, is a symbolic representation that the nucleus is constantly holding on the electron. तो ऐसे energy को negative नहीं बोलते हैं. Did you people get that? So please write down energy of electron in Bohr's orbit. Okay, now let's continue with the next postulate. Next is, this is not exactly a postulate, but ionization energy or ionization potential. Come on, can you people define for me what is IP? The amount of energy required to
remove an electron from the outermost shell of an
isolated, neutral isolated gaseous atom. So the amount of energy required to remove an electron from outermost shell of an isolated gaseous atom. ठीक है? So let's say we have people let's say this is our nucleus. And let's say we want to get rid of this electron. So what is ionization energy? So you're removing the electron, and where are you taking this electron? Basically, you are taking the electron away from the influence of the nucleus. So if I say this is, let's say, the nth orbit, this is somewhere at infinity. Did you people get that? So what is the formula for energy in terms of electron volts? Energy का formula क्या लिखा था हमने? Total energy is minus 13.6 into z square over n square. So in the nth orbit, what will the energy be? Minus 13.6 into z square upon n square electron volts. Excuse me. What will be the energy over here at the infinite orbit? Minus 13.6 into z square over infinity, like infinity square, तो नहीं था, infinity square is infinity. What do you get here, people? 0. Just what we were discussing while we were deriving total energy. So what will now be ionization potential or ionization energy? The energy in the infinite orbit minus energy in the nth orbit. This is the amount of energy that you have to supply in order to remove the electron. We'll do this thoda aur. I repeat, you're going from one shell to the other. How do we find the amount of energy required to go from one shell to the other? Let's say this is orbit number 1, orbit number 2. यहाँ पे एक electron है. I want to excite this electron from here to here. How much energy do I need to supply? कैसे करेंगे? Energy का formula, same thing. What will be the energy in the first orbit? Minus 13.6 into 1, let's assume hydrogen atom, 1 square by 1 square, so how much is that? Minus 13.6. I have to take it to the orbit number 2. What will the energy be over there? Minus 13.6 into 1 square by, ये कितना था? Minus 13.6 by 4. How much is that? Minus. So the energy in the first orbit is minus 13.6. Energy in the second is minus. So to go from here to here, how much energy was supplied? E2 minus E1, which is minus 3.4 minus 13.6. How much is that? So to go from here to here, I'll have to supply 10.2 electron volts. This confirms quantization of energy. That if you want the electron to go from one orbit to the other, specific amount of energy has to be supplied. ऐसा हम हर एक ट्रांजिशन के लिए एनर्जी निकाल सकते हैं. Similarly, so ionization potential will be energy at the infinite orbit is 0. nth orbit में कितना था? Minus 13.6 into z square by n square. Therefore, IP कितना मिलता है? Plus 13.6 into z square by. Find the ionization potential by using the same energy ka formula, but here it becomes plus 13.6 into z square by n square. Did you will get that? Next. Can someone define me what do you mean by time period? The amount of time taken to complete वेव थियरी में हमने पढ़ा था टाइम पीरियड इज द अमाउंट ऑफ टाइम टेकन टू कंप्लीट वन. यहाँ पे व्हाट इज टाइम पीरियड? टाइम टेकन बाय द इलेक्ट्रॉन टू कंप्लीट one revolution around the nucleus. So this is the nucleus. Sorry, one revolution, that is time period. We know that speed is, or velocity is, distance over time. So time can be written as distance over velocity. Please tell me, in one revolution, what is the distance that the electron is covering? In one revolution, what is the distance the electron covering?
2 pi.
Circumference. Excellent. 2 pi r. What is the formula for circumference, people? 2 pi r. Let's say velocity is v. Therefore, time period is equal to 2 pi. What's the formula for radius? Zero 0.529 into n square by z. Instead of 0.529, we can also write r naught into n square by z. What is the formula for velocity? V naught into z upon n. Therefore, time period is 2 pi r naught upon v naught. This z goes up, this n goes here, n cube by this term here is a, therefore time period is directly proportional to n cube over z square. What is the relation between time period and frequency? Frequency is 1 over टाइम पीरियड. तो फ्रीक्वेंसी का एक्सप्रेशन क्या मिलेगा? इसी का उल्टा, z squared upon n cube into, what do we have here? v naught upon 2 pi, or we can say that frequency is directly proportional to z square upon n cube. That's the expression for time period. Time taken by an electron to complete one revolution around the nucleus, and that is frequency, number of revolutions per second. With me? Next, go to the second postulate. What was the force of attraction between the nucleus and electron? I repeat, what was the force of attraction between the nucleus and electron? F is equal to k z e square upon r square. That was the force of attraction between nucleus and electron. R का expression क्या है? R is equal to 0.529 into n square by z, or r naught into n square by z. Substitute that here. F is equal to के जेड ई स्क्वायर अपॉन, ये क्या बन जाएगा, आर नॉट इंटू एन स्क्वायर बाई जेड द होल, हाउ मच इज दैट, के जेड ई स्क्वायर अपॉन आर नॉट स्क्वायर इंटू n raised to 4 upon z square, and this z is going to become z cube upon n raised to 4 kz upon, or the force of attraction between the nucleus and electron is directly proportional to z cube upon I'm so sorry, case, did I miss something? Pardon me, yes, I missed E. Kz E square. Sorry. K E square. Yes. These are the different expressions for force of attraction, time period and frequency. Chalo, start writing from ionization potential. ठीक, that completes postulates of Bohr's model. We stop here for the day. ठीक है, चेहरे पे क्या खुशी है. Next class we'll continue with the numericals on energy and the other Bohr postulates, and उसके बाद we'll start with atomic spectrum. ठीक है, where we'll study about hydrogen spectrum. ठीक है, चलो, thank you so much. I'll see you people next class.